Tahniah! Siaran langsung ini dibawakan khas kepada anda oleh Akademi YouTuber Malaysia, sebuah inisiatif e-didik Malaysia dan Kelab Guru Malaysia. Tumpukan perhatian anda, siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Okey, saya hari ini saya ada serangkap pantun. Okey, indah cahaya di senja petang, terpacak berdiri si anak dara. Pemanis kalam, selamat datang. Awal bismillah, pembuka bicara. Bismillahirrahmanirrahim. Assalamualaikum dan salam sejahtera semua. Saya Cikgu Rosmaliani binti Zaini, bertugas di SMK Bandar Bintulu Sarawak dari Akademi YouTuber bersiaran dari channel Cikgu Pe Kok Hua. Sebelum kita mulakan kelas kita pada petang ini, seperti biasa, lebih molek kiranya kita mulakan majlis ilmu kita dengan bacaan Ummul Kitab Al-Fatihah. Bismillahirrahmanirrahim. Amin amin ya rabbal alamin. Alhamdulillah bersiaran kita sekali lagi dalam kelas tuition online Akademi YouTuber yang juga merupakan kerjasama e-didik Malaysia dan juga Kelab Guru Malaysia. Sebelum kita mulakan kelas kita, ingin saya ingatkan kepada semua pelajar dan penonton yang ingin menghantar komen, sila gunakan bahasa yang sopan dan gambar profil yang bersesuaian untuk tontonan umum. Sila fokus pada isi pembelajaran yang akan disampaikan oleh Cikgu Pe. InsyaAllah semoga kelas kita ini akan dapat manfaat sepenuhnya oleh para pelajar. Ambil peluang ini, ikuti setiap kelas online percuma panitia fizik menengah atas yang akan bersiaran setiap minggu pada hari Ahad jam 2 petang. Baiklah, saya perkenalkan guru-guru yang ada bersama kita pada siri ini. Okey, Cikgu Kok Sima yang akan bertindak sebagai control host pada hari ini. Seterusnya Cikgu Rina Rashid selaku pemerhati pada hari ini. Dan juga ingin saya perkenalkan presenter kita pada petang ini iaitu Cikgu Pe Kok Hua yang kini bertugas di Kolej Tingkatan 6 Tun Fatimah Melaka. Okey, nanti beliau akan perkenalkan diri lebih detail lagi ya. Okey, juga diingatkan link sijil penyertaan akan diberikan di penghujung kelas ini. Sila ambil perhatian, link tersebut akan tamat dalam tempoh setengah jam selepas live. Hanya email e-didik, MyJawi, MOE dan MyGuru sahaja yang diterima. Okey, tanpa melengahkan masa, mari kita ikuti kelas fizik pada hari ini yang akan disampaikan oleh Cikgu Pe Kok Hua. Dengan segala hormatnya dipersilakan. Cikgu Pe.
Hai, selamat petang kepada semua pelajar, guru-guru dan juga ibu bapa. So, sebelum mulakan kelas, cikgu akan promosikan, kelas tuition percuma fizik SPM untuk AYU, iaitu di sini kamu boleh nampak, kelas tingkatan 4 diadakan pada setiap Jumaat 9.30 dan sekarang kita sudah sampai subtopik 24 inertia yang disampaikan oleh Cikgu Faizal, so kamu semua boleh pergilah visit, so channel Cikgu Faizal untuk subtopik ini. So untuk kelas tingkatan 5, seperti hari ini setiap Ahad pukul 2. So hari ini akan disampaikan oleh saya, Mr. Pe. So ini merupakan panitia fizik SPM Akademi YouTuber Malaysia. So hari ini bersama saya di konti ada Cikgu Kok, Cikgu Yani dan juga Cikgu Rina. So saya Mr. Pe kini mengajar di Kolej Tingkatan 6 Tun Fatimah Melaka. So kita sudah masuk bab kedua iaitu tekanan. So subtopik untuk hari ini adalah tekanan cecair. Subtopik 2.1 pressure in liquid. So in today's lesson, totally we have about 4 learning standards. First, you have to able to communicate about the concept of pressure in liquid with this formula, P equal to rho GH. Second, experiment to investigate factors affecting pressure in liquid. Third, solve problem involving pressure in liquid. So we will apply the formula P equal to rho GH for the problem solving related. And the last, communicate about the application of pressure in liquids in daily life. So total, we have 4 learning standards for subtopic today's. So before we going to our subtopic, there is the liquid pressure. So better we recall back the concept of pressure, which actually you have already learned in your Form 2, Chapter 8, Force and Motion. So first, there is the definition for the pressure. There is the force per unit area. Therefore, the formula for the pressure will be force divided by area. And we can use the symbol P represented as pressure, F as force, and A is area. The unit SI for the pressure will be Newton, which is the SI unit for force, divided by meter square, which is the SI unit for area. So we get Newton per meter square, which is also known as Pascal. And the relationship between the pressure, area, and force will be the first. If you, according to the formula, P equal to F over A, you may see that the pressure is directly proportional to F. And another one will be the relationship between the pressure with the area, which is inversely proportional. So therefore, we can apply the relationship between pressure, area, and force in our daily application. So here, forces adding on the smaller surface will produce a greater pressure and vice versa. So if you look at the formula, if we have the same value of the force with the smaller value of A, we will get greater value of force. Okay, and vice versa. So here we have 2 applications. So the first, we need to get high pressure, okay, for certain application. And another one, we need to get low pressure for another application. So how we can achieve high pressure? So if according to the relationship between pressure and area, so if we need to get high pressure, we need to have the small area. Okay, so smaller surface to produce higher pressure. So here we have one application. The tips of the pin, so will be here, point, has a very small surface area. When a small force is applied on the pin, so that means we apply the force on the top of the pin. So a very high pressure is produced to sink through the notice board. Okay, if you need to apply, you need to put the pin on the notice board. Okay, so the small area of the tips will let you more easier to put in the tips. Okay. And another one will be, we want to get the low pressure. So to get low pressure, okay, so to get low pressure, that means we need to increase our surface area. Okay, so here you can see the white shoulder pads, okay, is here. On the backpack are designed with large surface area to decrease the pressure assessed on your shoulder. This enable us to carry heavy load and yet to feel yet do not feel much pain. Okay, so this is the concept of pressure and the application, which actually you have already learned in your PT3. Okay, so here is also a recall question for application of pressure. Okay, so diagram 2 show a cuboid with a mass of 1.5 kg. So this is a cuboid, the mass given with a value of 1.5 kg. So what is the maximum pressure exerted by the cuboid when placed on the table? So you can see this is the surface which is exerted, okay, is weight on the table. So we need to get the area for this this part lah, okay. So for get the value for pressure, we need to apply a formula F over A. So the F will be weight of the cuboid, which is equal to mg. Okay, and then the area will be which the area which is I shaded with the red line already. Okay, so you can see here is actually 10 cm, and this part will be 15. Okay, so firstly we need to change the cm to SI unit, which is meter. Okay, so 10 cm becomes 0.10, and 15 cm will become 0.15 cm. So we get the area for the parts will be 0.015 meters square. Okay, so as mentioned, the weight is the force applied on the surface of the table. So m will be 1.5, which is given by the question, and G is the standard, okay, which is equal to 9.81. So we get the value for F will be 14.714 Newton. Then we substitute to the formula F equal to 14.714, and the area will be 0.015. So we get the final answer here. The pressure will be 981 Pascal. Okay. Okay, so the next here will be our first learning standard for subtopic today. Okay, so you have to able to communicate about the concept of pressure in liquid. Okay, P equal to rho GH. Okay, if you see just now the pressure, the formula is F over A. So here you will be know how we can use the knowledge which you already learned at science form 2, and you get this formula in this part. Okay, okay, so the first, how pressure in liquid happens. So a liquid in container exerts pressure because of its weight. Okay, so as per the example just now, okay, checkpoint 2.1 question 1. So the weight is actually due to the force is actually due to the weight of the cuboid. So here the liquid pressure, that means that the force applied on the certain surface is due to the weight of the liquid. Okay, okay, so we can prove that the weight is the force applied on the certain surface and cause the liquid pressure here. Okay, so this is a simple experiment. Okay, so let us read together the procedure and the observation. So take the balloon and tie it at the lower end of the glass tube. So you can look at the figure A, and haul vertically as in figure A. Okay, so this is what you can set up, okay, at your home also. Okay, okay, so pour some water in the tube. So you pour water into the tube, so the balloon bulges out. Okay, you can see this is what we call that bulges. Okay, in figure B. So why the balloon bulges? This is because the water column excess pressure at its bottom. So that means the weight of the water is actually the force, okay, for the case here. Okay, Okay, so let us see the discussion. Force on the balloon is equal to the weight of the water column. Okay, as per mentioned. So also pressure exerted by the water. So the area here will be area of the bottom of the tube. Okay, so that means that force over area. So we can see there is a pressure applied on the balloon and cause the balloon bulges. Okay, so the conclusion here, this show that the liquid exerted pressure at the bottom of the container because of weight of liquid. Okay. Okay, so then here we have the three characteristics of pressure in the liquid. So the first, pressure at any point in a liquid at a particular depth act equally in all directions. So this is a figure showing that. Okay, so the pressure is applied on a certain point and the water come out in all directions. Okay, the pressure liquid does not depend on the surface area and the shape or size of container. So you can see the surface area for here and here is different. Okay, where the first column here is a big surface area compared to another two tube. Okay, and the shape also different for these three tube. So, but you can see the water level is the same. Okay, if you take this part as a baseline, so that means that they have the same pressure. Okay, so the pressure is not depends on the different surface and also the shape. And the last one here is the pressure in liquid at any depth is equivalent. So that means if the hole is at the same level, okay, from the surface of water. So that means all the point will have the same pressure. Okay. Okay, so the factors that affect pressure in liquid, here we have the two factors which will be affecting the liquid pressure. So the first will be the depth. So here you can see there is the three different hole, okay, where they have the different position from the surface of the water. Okay, so that means you can see the result here show that the hole C spur out the furthest. Okay, so here we can say that the depth of the liquid increase, the pressure liquid will be increased. So later on we have the detailed discussion at the next slide. And another factor that affect the pressure in liquid will be the density. So here again you can look at the figure. The water density will be 1 gram per cm cube, and the cooking oil density is 0.93. Okay, so again you can see the water spur out, okay, at the same height, and the distance is greater, d1 greater than d2. So here show that the density of liquid increases, the pressure of liquid will be increased also. Okay, so here the relationship between the pressure of the liquid and the depth. Okay, so as per mentioned just now, as the depth increase, okay, we calculate, okay, we see from the surface of water, so that means the pressure will be increased. So we can conclude that the pressure is directly proportional to its depth. Okay, so from the figure, you can see that the water spur out faster and furthest from the lowest point. So we see. So this is because if we calculate, we see from the surface of water, so the hole C will be the deepest, okay, compared to hole B and A. Okay, so this shows that the pressure in liquid increases when the depth increases. Okay. Okay, so how about the relationship between the pressure of the liquid with the density? So as per mentioned just now, we know that the density of water is greater than cooking oil. Okay, when you mix two liquid together, okay, for sure that you can see the water is at bottom and the oil will be at the top. Okay, so we can conclude here the density of cooking oil will be lower lah compared to water. And you can see at the figure and clearly see that the distance of the water spurt out is higher for the water compared to cooking oil. So that means that the density higher, the liquid pressure will be also higher lah. So here the pressure is very proportional to density. So diagram shows water spurt out faster and further than cooking oil. Okay, you can see D1 is longer than D2 lah. So water has higher density than cooking oil. The pressure in a liquid increases when the density increases. So this is the factor affecting the liquid pressure. Okay, so derive the formula for liquid pressure. So for PT3, we know that the formula for the pressure will be F over A. Okay, so now we need to know how we get the formula P equal to rho Hg from F over A lah. Okay, so you can look at the diagram, okay? So diagram show a container with base area A. Okay, is filled to a depth of H. So the water surface is here to the base of the container. So here will be the depth of the liquid lah, okay? With the density liquid is rho. Okay, so here the volume of liquid will be base times height. So we get AH lah. And then the mass of the liquid, N, will be rho V. Why? Because the formula we know from the chapter 1.1, okay? So the density is equal to mass over volume. So that means we will arrange the formula, we get mass will be rho multiplied with the volume. And from the A, we get V equal to AH. Okay, so that means here we substitute as AH and we get rho AH. The next step will be the weight of the liquid. W equal to mg. Okay, so N we get from the V lah, which is equal to rho AH, and then we add on G. Okay, so the force on the base will be weight of the liquid as per discussion just now. Okay, so F equal to mg, you get rho A Hg. And finally, we get the liquid pressure will be equal to formula, which is learned from Form 1, F over A. Sorry, Form 2, Chapter 8, F over A. We substitute F equal to rho A Hg divided by A. So we cancel out the A. Finally, we get the liquid pressure equal to rho GH. Okay, so this is the discussion how we get the formula of the liquid pressure, which is equal to rho GH. So the rho represented as the density of the liquid. G will be the gravity acceleration. Okay, and H will be the depth of the liquid, which we see from the surface of the water, not the base of the water. Okay, from the surface. Okay. Okay, so we have finished the subtopic discussion of 2.1.1. Okay, the first.
Okay. Cikgu Peh, sebelum kita mulakan dengan question 2 tu, saya nak beri kod rahsia lah. 3 kod rahsia yang pertama, A25. Okay, A25 untuk kod kredit anda. Okay, teruskan Mr. Peh.
Okay, so let's take yourself, okay, whether you understand for the first Subtopik, okay? First learning standard of Subtopik today, okay? So diagram 1 shows the comparison between the pressure assessed by water P1, P2, and P3. So the P1 will be here, P2 will be here, P3 will be here. Okay, so which of the following comparison is correct? So A, B, C, D. Okay. So students, you may show your answer, okay, at the chat room, okay. Okay, so for answer this question, we have to apply the knowledge of the characteristic of pressure in the liquid. So just now we already discussed that the liquid is not depends on the surface area. So you can see the surface area for these 3 container is different. Okay, and then the shape also the different. Okay, and you can see here the height, the depth of the liquid is actually same for the PQR container. So that means that with the same depth of the liquid, showing they have the same liquid pressure. Okay, so the answer here is will be all the same lah, A. Okay, so the next question, question 3, diagram 8 shows 2 divers in a lake and a divers in the sea. Okay, so you can see lake we have 2 divers, T and S, and C we have another divers which is represented as U. So the pressure of water at T, S, and U is PT, PS, and PU. Okay, so from here you can see the level for the diver X will be shallower compared to T and U. So that means that the pressure for divers S will be the smallest. Okay, so here we have another T and U. So divers T and divers U is located at the same position, HT and HU. Okay, so suppose that pressure for T and U will be the same. Okay, you can see the discussion here. Okay, so pressure is directly proportional to the depth. So suppose they have the same pressure. Okay, so the height, the depth of the S will be lowest compared to T and U divers. So suppose we have to get PS less than PT, and PT is equal to PU. But for the seawater, okay, for the seawater, so the density of the sea water compared to the water in the lake would be different. So as we mentioned that the density for liquid increase, the pressure will be increased. So that means that the pressure U will be the greatest. Okay, so that means here the answer will be actually A. Answer will be A. Okay, because the density of the sea water is greater than the water in the lake. Okay, so the density faced by the diver U will be greater than T. So answer is A. Okay, so we go to our next question. Question 4 will be the application for the formula liquid pressure. So the diagram below shows an air bubbles in the seawater. So the bubble is here, and the position of the bubble is 15 meters below the surface of the sea. Okay, so the sea water density will be 1040 kg per meter cube. Okay, so this is a quite simple question. We just apply the formula. Okay, because the question asks us to find the pressure at the point here. So rho will be the density of the water, seawater. H will be the position of the bubble from the surface of water, and G is equal to 9.81. So we substitute the value, we get the liquid pressure will be 153,000 and 36, okay, Newton per meter square. Or you can put Pascal also. Your answer must be with the correct unit. Okay, so the next question will be the question paper 2, section A. Okay, so diagram 1 shows a container filled with the liquid Y. Okay, so this is a liquid Y. Liquid Y spurt out through a hole at the horizontal distance. So we here. The hole will be here and spout out distance will be here, D, due to the pressure. So what is the meaning of pressure? So as per discussion and recall section just now, okay, so the formula for pressure will be F over A. Okay, you can change to the sentence which is force per unit area lah. So you'll get 1 mark. Okay, so another question here, give 2 factors that affect the pressure in liquid. Okay, so the pressure of liquid, we have the formula rho Hg. So rho represented as the density of liquid. H will be the depth, okay, depth of the liquid, and the G will be gravitational field strength, okay, which is also known as the gravity acceleration. Okay, so next will be calculate the pressure in the liquid Y at the hole. So the hole will be here. So the distance, as mentioned, the depth we need to calculate. We need to see from the surface of the sea, surface of the liquid. Okay, so will be represented at the H here. So that means the H here will be 4 minus 2.5. So we get the H depth is actually 1.5. G will be standard, which is equal to 9.81. And rho given by the question is equal to 1000. We substitute to the formula and we get the value 14,715 Newton per meter square. First mark for the substitution. Second mark will be for the answer with correct unit. Okay, then D. What will happen on the horizontal distance when liquid Y is replaced by higher density liquid? Okay, so what happened to this value D? Will be further close to the container or remain the same? Okay, so here the question asks us to predict, okay, the distance for D with the higher density of liquid. So as per mentioned, with this formula, density increase, the pressure of liquid will be increased. So when the pressure liquid increase, so the liquid will be spurred up further. So that means D will be increases. Okay. Okay, so next will be our learning standard 2, experiment to investigate factors affecting pressure in liquids. As per mentioned just now, we have 2 factors, okay, that actually affected the pressure in liquid, which is depth and also the density of liquid. So that means here we have 2 experiments to discuss. And these 2 experiments is actually 2 of the compulsory experiment, okay, for syllabus form 5. Okay, so that means that there will be very high chance that come up at your actual paper 3. Okay, because the apparatus I see that is also quite cost effective. So that means they might be possible, okay, to come up in your paper 3. Okay. Okay, so to study the relationship between the depth of the liquid and also the pressure in liquid. Okay, so the inference, the pressure in the liquid depends on depth of the liquid. Okay, so how we can write the sentences for the inference? Okay, you can see here we can identify the responding variable here, which is the pressure of liquid, and manipulated variable for the experiment here, which is the depth of the liquid. So you just put RV depends on MV. So this is the method how you write your answer for inference. Okay. Okay, so hypothesis also the same. You must relate your responding variable and the manipulated variable. So here, when a depth of liquid increases, so the depth of liquid referring to the MV, so pressure liquid will be also increases. Okay, because pressure and liquid, pressure of liquid and depth is directly proportional to each other. Okay, so the aim to investigate the relationship of the depth. So this is also the MV, and pressure of liquid will be the RV. So you can see the inference, hypothesis, and aim, three of these terms. Okay, you need to just identify the MV and RV for the question. Okay. Okay, so the manipulated variable here, as mentioned, very clear just now. Okay, so it will be the depth of the liquid. Responding will be the pressure of the liquid. Okay, so the factor affecting the liquid pressure will be depth and also the density of liquid. So here we must using the same liquid for this experiment. So the type of liquid must be the same. Okay, or you can just mention density of the liquid. I think this is also a correct answer. Okay, so for this experiment, the apparatus will be the tester funnel. Okay, we heat this rubber tube here. Meter rule here, retort stand. Okay, retort stand not mentioned in this figure. Okay, it is using to holding the meter rule. Okay, plan measuring cylinder will be here, and the manometer. Okay, so the manometer can just using the simple rubber tube also can actually. Okay. Okay, so the material will be the thin rubber piece and water. So the thin rubber piece will be at here actually. Okay, so the paper 3 question, the apparatus and the material will be given. Okay, so if let's say the question is the type of the guided, okay, jenis berbantu, so that means the arrangement of the apparatus will be also given. Okay, so the procedure here, the first will be apparatus is arranged. Okay, is arranged as shown in the diagram above. The tester funnel is lower into the water with a depth of 10. So you can see the X value for your first reading will be, manipulated reading will be 10. So you must measure from the top of surface to the base of the tester funnel here. So it must be 10. And then you must see your H value here. The H value here is the level of highest level of the manometer with the lowest. Okay, so that means from here to here will be the H. So you have to record your first responding variable. Okay, so the step will be repeating with the X equal to 20. That means that you have to put in, you can look at the figure, you must put in and measure your S equal to 20 cm, and again get your H value when your X equal to 20. Okay, and then 30, 40, 50, and 60. Normally, we need to have the at least 5 reading. But if I say the question is the jenis berbantu, that means we have to follow all the reading given by the question. Okay, so we measure our H, okay, the face value here. This is just the reference value, okay, 0.74. So for the 20 cm, so we expected the value must be greater than 0.74, okay, because the pressure of liquid is directly proportional to the depth of liquid, okay, so it will be higher. So if let's say you get the trend which is increasing, so that means your experiment is correct. Okay, the next step will be plot your graph H against X. This is the experiment, compulsory experiment. So that means everything you can just get from your textbook. Okay, and we plot the first point will be 10 and 0.74 for H. For others point also the same way we plot. So we expected we get the straight line which is pass through the origin, which is show that the H is directly proportional to X. Okay, so the liquid pressure of liquid increases with the increasing of the depth. So this is the experiment showing that our hypothesis is actually accepted. Okay, so the next will be the study relationship between the density of liquid with the pressure of liquid. So the same inference will be the pressure in liquid depends on the density of liquid. So the MV will be density of liquid. So we will be using different liquid in this experiment. Okay, and the RV will be also the same. We measure the H, which is represented as the pressure in the liquid. Okay, so hypothesis also the same. We know the MV is density of liquid, RV will be the pressure. So when the density of liquid higher, the pressure of liquid will be also increased. Okay, it will be higher. So that means the value of H will be higher. Okay, so the aim for the experiment to investigate the relationship between the density and the pressure in the liquid. So the density will be the MV and the pressure will be the RV. Okay. Okay, so the manipulator we're using the different liquid. So here, density of liquid will be the factor we study in this experiment. So will be the manipulated. And the responding here will be the same value of H, which is the pressure in liquid. And because of the density of liquid become the manipulated variable and what we need to study. So that means the depth of the liquid represented as X here will be always the same. Okay, become the constant variable, okay, for this experiment. Okay, so the apparatus will be the same and the material will be different. Okay, just now we're using only water, which is represented as the 1000 kg per meter cube. Here we have another two liquid with different density. We're using the alcohol, which have the 800 kg per meter cube, so which is lower than the water. Okay, and glycerin, okay, using the glycerin with the density of 1300. So that means we expected that the H value for the alcohol will be the lowest and the highest will be the glycerin. So before we do the experiment, especially for your paper 3, you need to know what is the trend. Okay, what is the trend for your result? Okay, so that you're not wasting a lot of time to repeating your experiment. End up you cannot answering your paper sheet, answer sheet, because the marker is marking the answer sheet, not how you're doing the experiment. Okay. Okay, so again, the procedure, okay, you have to set out the apparatus shown in the figure, and here the X will be 50 cm. So that means the X is always 50, and you measure your, you read your value of H here. Okay, and then the procedure is repeated by using the different liquid, which is the alcohol and the glycerin. Okay, so again, we expected our first value if with the density with 100, so with 1000 will be higher than 2.94 lah. Okay, here the reference answer here is 3.68, and the highest will be the glycerin, which is mentioned just now. So we also expected our graph will be direct proportional. That means it will be the straight line passing through the origin. Okay, so the conclusion, the pressure of liquid increases with the density. Okay. Okay, so terima kasih cikgu Faizal dengan cikgu Hasita, okay, join bersama kita, okay. Okay, so now look at the checkpoint for this section, learning standard 2, okay. So diagram 8 shows an apparatus set up to measure pressure in liquid. So what happened to the height H if the piston funnel is lower from level P to level Q? So expansion, we see the depth of the water from the surface. So that means the depth of the P is lower compared to the H. So that means the pressure, which is directly proportional to the depth, showing that at the position Q will be increases lah. Okay, answer will be A. Okay, so now we go to our next question, question 7, before we go to rest, okay? Okay, so diagram 4.1 and 4.2 shows an apparatus of an experiment to determine the factor that affect the pressure in liquid. So the factor, as per mentioned, we have two factors affecting the liquid pressure. First will be the depth of liquid, and the second will be density of liquid. Okay, so here, the first question asking you to comparison the depth D of the distal funnel immersed in water. Okay, so this is an example of question conception, which you will be faced at the section A, question 5, 6, and also the section C, if I'm not mistaken. Okay. Okay, so we just look at the D. Okay, if I say you not study, okay, you just look at the D. You can see that the value D1 is greater than D2. Okay, so D1 is greater than D2. So that means answer here will be 4.1 greater than 4.2. Okay, you can just using the simple mathematics here. So comparison for the height. So that means if I say you do know everything, you look at the figure, where is the H? We can see very clear that H1 is greater than H2. So you just mentioned diagram 4.1 is greater than 4.2 with the symbol. Okay. Okay, and then the next will be the relationship between the depth and the height. Okay. So as per mentioned just now, we just comparing our D and the H. So when the D increase, the H increase. So that means that the depth of the liquid increase, the difference of the height of the mercury column increase. So you just add on two words here, increase, increase. Okay, the depth, the deeper the depth, the higher the difference of the height of the mercury column. So you just copy the sentence from the question. Okay, so the next will be the relationship between the depth and the liquid. The depth and the pressure. Okay, so the depth and the pressure will be directly proportional here. So the deeper the depth, the higher the pressure. Okay. Okay, so B, if the experiment above is conducted in the moon, what happened to the difference of the height mercury column in the manometer H1? So you can look at the H1. So what is the difference between the moon and the earth? So there will be, okay, you will be see again the formula, rho heat G. So the difference here will be the G, the gravitational acceleration will be smaller for moon compared to earth. Okay, so that means that the value of G decrease causes the value of pressure liquid decrease. So that means that the H value will be decreases. Okay, so why? Because the moon has a lower gravitational field of strength. Okay, or you can just mention lower gravity acceleration also can. Okay, so that's all for the second learning standard. Okay, we can just take 5.
Okey, kita berehat dulu 5 minit.
Berita baik untuk semua. Kini, Akademi YouTuber memperkenalkan sistem mata ganjaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.academyyoutuber.com Untuk maklumat lanjut.
Okey, sebelum kita teruskan pembelajaran kita, saya nak bagi satu lagi ya. Nombor tengah untuk kod rahsia kita iaitu nombor 9. Okey, nombor 9. Nanti ada 2 lagi. Okey, teruskan Mr. Pei.
Okay. Okay, thank you, Cikgu Yani. Okay, so we continue for our third learning standard, solve problem involving pressure in liquid. Okay, actually this is just application of the formula P equal to rho Hg lah. Okay, so let us discuss another 2 questions here. So the diagram below shows the container. So this is a container. The surface area is 50 cm3. The container is filled with the liquid of the density of 1,200 kg per meter cube. So calculate the pressure acting on the base. Okay, base of the container. Okay, so again, the weight will be the weight of the liquid lah. Okay, so here the liquid pressure is affected by rho Hg. So the value of the area is not used actually. Okay, so the density of the liquid will be 1,300. G is equal to 9.81. And the H will be 25 cm minus with 5 because we want to get the height of the water, sorry, of the liquid here. Okay, we get 25 minus 5, 20 cm, we change to SI unit 0.2 meter. Okay, so we substitute to the formula, we get answer will be 2,550.6 Newton per meter square. So again, reminding you that you must keep your answer, okay, with correct unit. Okay, so the next question, the diagram shows the surface. Okay, show the surface of water in domestic water tank with which is 5 meter above. So 5 meter above here. So again, as mentioned, we see from the surface of the liquid. Okay, 5 meter above the deck downstairs. So here. So what is the water pressure in the deck? So here again, water pressure will be applying the same formula. Okay, rho Hg. Question given, density of liquid will be 1,000. Okay, and H is 5. And G is always 9.81, which is stated at the formula sheet, okay, at your question. So you just apply to the formula, you get the value will be 49,050 Newton per meter square. Okay, so we go to our last learning standard today. So learning standard 4, communicate about the application of pressure in liquid in daily life. Okay, so the first application here will be the water tank. Okay, you can see the water tank, okay, is always at the high position. Okay, water that is supplied to consumer is stored in tank at high level to produce high pressure. This is H. The greater value of H, the greater the liquid pressure. Okay, so the answer will be high. Okay, so the second application here we need to discuss regarding the dam. Okay, so you can look at the figure here. This is the design of the dam. So the wall is thinner at the top and the base will be thicker. Okay, why? Because you can see as the water depth increases, the liquid pressure will be increases. If let's say the wall of the dam is thinner at the base, so it will be unable to withstand the high pressure, okay, adding on the base of the dam lah, okay. So the wall of the dam is much thicker at the bottom. The pressure of the water is higher at the bottom of the dam. So the pressure is directly proportional to that. So this is the 3-mark question, okay. Maybe can be asked at the section B or C lah, huh? Okay, so the application here, the next will be intravenous bag, okay. So the intravenous bag will be here. Again, will be placed at a high position. The higher the intravenous bag put, so that means the higher the liquid pressure will be flow through the vein. Okay, so the vein has its own blood pressure. So that means we need to have the certain position, okay, to overcome the blood pressure in the body so that the liquid which need to apply in the body can flow through. Okay, so in the hospital, an intravenous bag is placed higher than a patient. So normally this will be the first mark. So he or she receive when he or she receiving therapy, intravenous therapy, such arrangement allow the intravenous fluid in the bag to have enough pressure to flow into the patient. Okay, so the enough pressure means that the pressure here is greater than the blood pressure of the patient. Okay, then the fourth application here will be the siphon. So a siphon is very useful for removing liquid from a water tank or a fixed container. So normally, example, we want to clean up the water from aquarium. So you will be apply this method also lah. Okay, so maybe you not realize that actually you apply the siphon or the liquid pressure concept in your daily life lah. Huh? Okay, so the first already read. Okay, the second, the difference in the water level will cause the difference in pressure. So you can see the water level here mentioned will be here, the line ABC here, which is equal to the atmospheric pressure. Okay, and another level here will be level D. So you can see here also a H here. So this is the different pressure lah. Okay, so the water pressure at C is same as the atmospheric pressure at A and B. So here I stated as the dotted line. Okay, the water pressure at D here, okay, will be atmospheric pressure plus liquid pressure. We're using formula rho GH. So the H will be the different level between this red line to the surface of the D line. Okay, so the last application we want to discuss here will be the YouTube. Okay, so this apparatus is used to compare the density of two immiscible liquid. So you can see from the figure, here we have two liquid with different density, liquid P and liquid Q. Okay, so YouTube filled with liquid P, so here, then it is added with liquid Q. So you can see here, we added another liquid Q, which does not mix with liquid P. Okay, so both liquid will be not mixed together. Example, oil with water lah. Okay, so the liquid pressure at point A here, at this point. So we're using the formula H rho G. So the H will be the height from the surface to point A. Okay, then rho 1 will be represented as a density of P, density liquid P. Okay, we do know what is the liquid here lah. Then G, we conduct the experiment at the Earth. So here will be only G lah. So that means it's always the same. Unless you conduct your experiment at Earth and the Moon, the G will be the different. But here will be the same lah. So the second liquid here, we also apply the same formula. Just the difference here will be the H2 is different. Okay, you can see the H2 here at the figure. And also the density of liquid will be different. So G will be the same. As per mentioned, we conduct the experiment at the same place on Earth. Okay, so the point A and B are at the same level. You can see the red dotted line. So A and B point will be same level. Normally, we will take the point where is the boundary between the liquid P and Q lah, huh? Okay, so this will be the point. This will be the line we get. Okay, and both liquid are not moving. So the pressure A and pressure B is equal. So that means the P1 and P2 will be same lah. So that means here P1, here P2, both will be the same. So P1 will be equal to H1 row 1 G. H2 will be H2 row 2 G. So we cancel out G because both have the same value. Therefore, we get the relationship between both density of the liquid will be H1 row 1 equal to H2 row 2 if we conducting the experiment in the Earth. Okay, or both is at the moon also one, the G will be the same. Okay, so here we discuss another two questions, okay, for this last learning standard 4. Okay, the diagram below shows the U-tube containing water and oil. So here you can see oil will be at the dark color. Okay, so if the density of water is 1 gram per cm cube, calculate the density of oil. So we're using the same concept we have already learned just now. Okay, so the point A, so A will be the boundary point between the oil and the water. So here will be the level we consider as same level. So we get point B. Okay, so we get the formula just now. G will be the same. We cancel out. We get HA rho A equal to HB rho B. Okay, so the A will be represented as the oil density. Okay, rho A. Rho B will be the density of the water. Okay, which is equal to 1 given by the question. And the HA will be HCN. You can look at the figure. And the HB will be 6. Okay, according to picture. We substitute all the value to the formula, to this formula. Okay, so we get our rho A, which is the density of the oil, is equal to 0.75. Okay, gram per cm cube. Okay, so this is the answer. Okay, so this is the last question for the discussion today. Okay, so this is a sample question for section A, paper 2. Okay, diagram shows U-tube contains liquid A and liquid B. Okay, here will be liquid A, here will be liquid B. So you can see the A is floated on the B. So the density of A must be lower than A. Okay, if I say the question asks you to get the answer. So this is what you can just verify whether your answer is correct or not. Okay. Okay, so the density of the liquid A is given as 1.5 gram per cm cube. Is the pressure at P same as pressure at Q? So P is here, Q is here. Is it both same? So pressure at point P and Q is not equal. Why? Because you can see the point P and point Q both is located at different liquid. Okay, so the density of A and B is different. So the next, compare the pressure at R and S. Okay, R will be here, S will be here. You can see the R is the point at the boundary of the liquid A and B. Okay, so that means both is actually same level and at the same type of liquid. Okay, so here comparison for R and S. So since the question is 2 marks, you have to have 2 points. So the first, pressure R same as S, first mark. So both is at the same level, will be your second mark. Okay, so the last question will be calculate the density of B. So as per mentioned just now, we can know that the liquid value, density for liquid value B must be greater than A, because you can see the A is float on the liquid B. So this is what prediction you can make before your calculation. Okay, so again, we're using the same formula. Okay, both position R and S have the same pressure, and we're using the same formula, rho H rho G. We cancel out the G, you can straight away go to this formula. Okay, A represented as the liquid A, B represented as the value for liquid B. So question given that the density liquid A will be 1.5. So that means your value for liquid B must be greater than 1.5. Okay. From the figure we get the HA is 6 and the HB is 12. Substitute to the substitute to the formula, we get B. Here B will be 0.65. Okay, so this is what we get now. Okay, so this will be the all discussion of today. Okay, so Cikgu Yani, so I pass back to you.
Okey, terima kasih kepada Cikgu Pei. Sebelum tu saya nak berikan dua lagi kod kredit yang terakhir ya. Nombor 66. Nombor 66. Kemudian okey, jap. Okay, terima kasih kepada Cikgu Peko Hua atas perkongsian yang sangat padat dengan info yang menarik. Tahniah diucapkan kepada semua yang setia walaupun kita tidak ramai ya petang ni yang masih setia bersama kita dari awal hingga ke saat ini ya. Okey, sekarang sebelum link sijil sudah letak link sijil sudah pun diletakkan di ruangan chat. Okey. Sesiapa yang belum subscribe Cikgu Pei, sila subscribe Cikgu Pei sebagai kita beri penghargaan kepada beliau. Okey, sekarang link sudah dimasukkan. Link ini akan tamat pada tempoh setengah jam selepas live ini ya. Pastikan anda menggunakan email e-didik, MyJawi, MyGuru atau MOE saja untuk mengisi borang sijil. Kelas seterusnya untuk subjek fizik adalah pada hari dan waktu yang sama pada minggu hadapan. Tolong sampaikan kepada rakan-rakan kamu semua ya. Sila layari www.akademiyoutuber.com untuk dapatkan info terkini dan jadual kelas tuisyen percuma ini. Anda juga boleh vote cikgu-cikgu kegemaran anda di portal ini ya. Jom kongsikan portal ini kepada rakan-rakan dan guru-guru seluruh Malaysia. Juga diingatkan semua kelas online percuma ini boleh ditonton semula melalui link yang disediakan di portal AYU. Okey, presenter. Okey, seterusnya semoga kita mendapat manfaat dari kelas-kelas yang dijalankan. Ingat hashtag bermula percuma, selamanya percuma. Okay, kita ada penggulungan ke Cikgu Pei?
Sorry?
Kita ada penggulungan tak petang ni? Cikgu?
Tak ada.
Okey, kita gulung sekejap lah. Okey. Kita mula daripada Cikgu Kok.
Nak apa? Nak cakap ucapannya apa?
Sepatah dua kata.
Okey, tak ada apa-apalah. Hanya pesan belajar dengan belajar bersungguh-sungguh lah. Walaupun sekarangnya lah bulan Mei kan. Untuk belajar tingkatan 5 sebenarnya masa tak banyak lah. Kerana kami tolakkan cuti-cuti. Lepas tu SPM akan coming soon lah. So belajar jangan buang masa lagi kerana kami nak belajar form 4 dan belajar form 5 ada banyak topik. Sebab banyak form 4 dah lupa kan, kena buat ulang kaji. Okay, so ini pesanan daripada cikgu lah. Okay, selamat
belajar. Terima kasih Cikgu Kok. Okay, seterusnya Cikgu Rina.
Okey, terima kasih kepada moderator dan tahniah dan syabas kepada Cikgu Pei kerana berjayalah sebagai presenter untuk hari ini membentangkan mengajar kita berkongsi ilmu tajuk Tekanan Cecair dan ia adalah salah satu topik lah yang popular boleh katakan untuk tajuk ni. Nanti kalau dia berkait rapat dengan tajuk-tajuk seterusnya prinsip Bernoulli, jadi anda perlulah tahu tentang basic dia tekanan cecair ni lah, pressure in liquid ni. Okey, saya ada sedikit pantun lah untuk diberikan kepada para pelajar. Pahit itu ramuan jamu, rasa pahitnya tak jemu-jemu. Bergiatlah dalam menuntut ilmu agar jadi orang yang berguna dengan ilmu tu kan. Okey, saya serahkan itu saja kepada moderator kembali. Terima kasih.
Okey, terima kasih Cikgu Rina. Okey, daripada saya sendiri, terima kasih kepada penonton dan pelajar yang setia bersama dengan kami di channel ini daripada awal sehingga akhir. Dan semoga berjaya dan good luck kepada semua. Okey, seterusnya Mr. Peh.
Saya nak ucap terima kasih lah kepada cikgu-cikgu hari ini yang bersama saya. Okay, so Cikgu Kok, Cikgu Rina dan juga Cikgu Yani. Okay, so walaupun sekarang sudah buka sekolah, so tim kita masih kekal memberi sumbangan kepada para pelajar dan para guru. So saya harap para pelajar dan para guru boleh continue support kita tim AYU kumpulan fizik lah. Itu saja.
Okey, yang baik datangnya daripada Allah dan sebarang kekurangan datang daripada kelemahan kami sendiri. Bunga dedap di atas para, anak dusun pasang pelita. Andai tersilap tutur bicara, jari disusun, maaf dipinta. Sekian, terima kasih. Jumpa lagi di minggu hadapan. Assalamualaikum. Bye-bye.
Semua sekolah ditutup hingga cuti akhir tahun 17 Disember 2020. Anda tak cukup bahan? Tak ada rujukan? Tak faham? Anda nak tuition tapi PKP? Jangan risau, kami di Akademi YouTuber dengan kerjasama Kelab Guru Malaysia dan e-Didik Malaysia mengadakan kelas tuition online. Semua peringkat ada, semuanya secara percuma. Video PDPC pun ada. Apa ditunggu lagi? Layari www.academyyoutuber.com.
Dibawakan kepada anda